In this video, we are going to solve some examples of circular permutation. So let's begin. People around round table. Let's use that as the first scenario. So in how many ways can 5 distinct people be seated around a table? In how many ways can 5 distinct people be seated around a table? So here we have the total number to be equal to 5. Since each person is distinct, please, it's very important. Each person is distinct, is different, and their relative positions matters. We use the standard circular permutation formula. That is what we stated. So this is the formula to use. Therefore, the permutation. Now, you see, anytime we are talking about permutation, unless as we stated earlier, one of the characteristics of permutation is unless specified, every object must be distinct. They must not repeat, unless cases where it is with repetition. That one need to be stated. If not, it means that they should be distinct. They should be distinct. So here, this is our normal formula. So we have this minus 1, and then you understand how this was obtained. So we have the total number of people to be 5 and then minus 1, and this is what we have as our final results. Now here we are going to consider a special case. Now here, keys on a ring. You realize that keys on a ring is not the same as people sitting around the table, because keys on a ring, if I hold one key at a position, if I mark one side of a key of a ring, just mark one side and rotate the key from that point until I get to that point, it's one rotation. It could be clockwise or anti or counterclockwise. It still comes to the same place. So since we can't differentiate whichever way we went to get to that position, it means that that is not a typical example of circular permutation. It's a special case or a different type of circular permutation. We need to understand this. That people sitting around the table, or when objects are arranged around a circular object or circular table, it means that different people, to be specific or to be precise, different people are seated or different objects are arranged around a table. Then we use the circular permutation formula. But then when it is a ring or a bead, where rotation, you realize that when with the people sitting around or the different objects arranged around the table, you can clearly see that anytime there is a change in rotation, as we did in the previous video, anytime there is a change in the rotation, though the people will be the same, but then the arrangement will change. So permutation is about the order of arrangement. There's going to be a different permutation when people around a table undergo rotation. If they undergo clockwise rotation, there will be, if one person undergoes a clockwise rotation, there will be a different permutation. And if that same person undergoes a counterclockwise rotation, there will also be another permutation. So you realize that it's not the same. But when you consider cases of keys and beads on a string, anytime a key undergoes clockwise rotation, one permutation is obtained, and if it undergoes counterclockwise rotation too, just the same permutation is obtained. So with this one, just understand that okay, you have to use the circular permutation and then divide it by 2. So here you realize that we have, in how many ways can 6 distinct keys be arranged on a key? 6 distinct keys be arranged on a key ring. How can they be arranged on a key ring? So here, how many keys? Please, they should all be distinct. The common denominator or the common factor is that they should all be distinct, whether around a key, whether around in a ring, they are arranged in a ring or in a string. They should all be distinct. But then the difference is that is the rotation. You see, around the table, when counterclockwise rotation is made, a different permutation is obtained, and when clockwise rotation is also made, a different permutation is obtained. But then when it comes to keys on a ring or beads on a string, anytime counterclockwise rotation is made, you realize that the same permutation is made. And whenever counterclockwise rotation is also made. The same permutation is also made. So in any of this instance, you divide by 2. So here we have 6. So what we did, the total is 6. So we took the circular permutation and divided it by 2, and we got 60 examples. And then here too we have the third example is arranging different colored flowers. Is the same thing. In how many ways can 7 different colored flowers be strung together to form a necklace? So we are holding a flower, okay? You are using a flower to form a necklace so that you can put it around your neck, and then when you are going for a ceremony or a function, you can use that. Anytime you hold one flower and rotate it clockwise, it will come to the same place. And anytime it is also rotated counterclockwise, it will come to the same place. So the formula you need to use is always use the permutation, the circular permutation formula, and divided by 2. So the total number of distinct flowers is 7, and then so you subtracted 1 from it, you take the factorial, 6 factorial, then over 2. The 2 is constant. The 2 signifies that it's going to be half of. The 2 means that we are taking half of it. We are taking half of. So let's say that anytime you take clockwise, you get 1, and anytime you take counterclockwise for circular permutation, you get 2. But here, if you take 1 counterclockwise, you get the same. If you take clockwise, you get the same. That's why it is 2. To divide it, to say that you get 1, because if you have 2 and you divide it by 2, you get 1. So that's what it means. So we are dividing the counterclockwise by that, and then everything becomes the same. Thanks for watching, and let's meet in the next video. Bye.